Yeah, so number of electrons that any atom wants to have in the last shell, it is either 0 or it is 8. Okay, and that is called octet rule, right? So according to octet rule, any atom would like to have 8 in the last shell. That means that you can have up to 8 according to that. And that is why we have 8 groups in the periodic table. The last shell, when it gets to 8, it moves on and a new shell is formed. So that is how it is, that you can see these groups, there are 8 groups. And the reason is that when they reach 8 in the last shell, they become stable. So group is related to the number of valence electrons. Now that is also related to another thing which we call valency or the charge or ion. So remember one thing, any atom wants to get to 0 or 8 in the last shell. So let's suppose an atom has 1 electron. So it will try to make it 0 somehow. And the best way to do that, to make an electron shell having 0 electron, is to lose the electrons that it has. Okay, so it has 1 electron, it will simply lose that one. Similarly, if an electron has 2 electrons if an atom has 2 electrons in the last shell, it will be in group 2, which means that it has 2 in the last shell. But it can simply lose them and get to 0 because it is closer to 0. Similarly, if it has 3, then it is again closer to 0 compared to 8. So it will try to lose those 3 as well. If it gets to 4, things get a little tricky. It can either lose all of them or it can just get 4 more and make 8, right? And usually what they try to do is they make it 8. Now, if it has 5 in the last shell, which means it will be in group 5. So losing 5 will require more energy compared to just gaining 3 more electrons. So we say that gaining 3 is easier. And that's what it does. It simply gains 3 more electrons. Group 6 will obviously gain 2 more electrons. 7 will get 1 more electron. And when it has 8, it doesn't need to do anything. It is already where it is stable. And that is why the things that are already naturally having 8 in the last shell are called noble gases. And they are what we call inert. They do not react easily. Although when the atom becomes bigger, it starts to react, which is why we have some compounds of xenon and radon, which are the bigger noble gases. But in O levels, we can simply go with it that they're inert because they don't need to react to make 8. They already have it. But the rest of them, they want to get to 8. Now, the closer they are, the more impatient they are. So if something has 1 electron and wants to get to 0, it will try to do it as fast as it can, which is why the things in group 1 are very reactive. Although, also a reason is, the technical reason for this is that losing 1 electron is much easier. It requires a very little energy, which is why they're more reactive. Similarly, group 2, they want to lose 2 electrons because they want to get to 0. Getting 6 more to get to 8 is more difficult. So they will simply lose 2 electrons. So while they can lose them better than those in group 3 because they have 3 electrons to lose, they're still short or less reactive than those in group 1 because group 1 will still find it easier and still beat them at it. Okay. So the smaller the number, more reactive it is when it comes to losing electrons, and larger the number, more reactive it is when it comes to gaining electrons, which is why if something is in group 7, that means it will readily gain 1 electron. So the energy required to do that or energy involved in doing that is less compared to if it had to gain 2 or if it had to gain 3. Okay, so that is why they will prefer to get to 8, and those that prefer to get to 0, they are the ones in 1, 2, 3 and all that. Now the things that usually prefers to do that, we call them metals. So metals are the ones that usually prefer to lose electrons. And you see that staircase here. That staircase basically outlines the metals. So things on the left side are metallic, things on the right side are non-metallic. And there's a term that examiner uses, it's called metallic character. Now metallic character simply means that it has a tendency to lose electrons. So that means things that are in group 1, they are more metallic than things that are in group 2. Why? Because the things in group 1 can lose electron much faster than group 2. And the reason is because they want to get to 0, the energy required is less. Okay? So that's the thing. Metallic character of things in group 1 is higher than group 2, then group 3, and non-metallic character is highest in 7, because they just want to get an electron, whatever it takes, and do that readily. All right, so that's group 7 on one side and group 1 on the other side. So let's talk about those that do not react at all. This group 7, noble gases, they're unreactive, they do not form ions, they do not react, which is why they're useful when we have environments where we don't want things to react. For example, when we're filling balloons, or when we're filling uh, tires for racing cars like Formula One, where the even the slightest explosion can lead to catastrophe. We try to use helium. Number one, it is light, and number two, it does not react. Which means if there's an explosion or if something bursts, we do not have the risk of something catching on fire because of helium. But imagine you put hydrogen in. Now, hydrogen molecule is half the mass of helium, so you will need less amount of hydrogen, and it might be lighter. But the thing is again that hydrogen is explosive. So helium is much, much safer, even though it doubles the mass. So, and still a compromise compared to oxygen, which is 16. In fact, 32 is the mass of oxygen molecule. So we use helium to fill balloons, car tires, and such things where we need them. And the reason is that it is light. Neon, again, we use it when we have high current flowing and we want light or light energy to come out of that. So again, if it was any other thing, it is very much possible that it will react. For example, we fill argon in light bulbs. The temperatures can go up to 2000 degrees Celsius, and at that temperature, the tungsten metal in the bulb can react with oxygen in the air. But because it is filled with argon, it does not react, even at such high temperatures. And the reason it doesn't react is because it already has 8 in the last shell. Same for neon, it doesn't react even though the current coming through is really, really high. So neon lights, they give us bright colors, but when you turn them off, the reaction hasn't happened and you can reuse it. If the reaction had happened, you wouldn't be able to reuse it. It would have been damaged in some way that makes it unusable. Similarly, when we're making steel, we have carbon, we have iron, we are reacting those things, we are combining those things in a certain ratio, and the temperature is quite high. Now, imagine if you had that high temperature and you reacted carbon there. So, carbon will simply react with oxygen in the air and it will burn. So, you won't be able to make steel. In fact, you will have just carbon going out, extreme energy coming out, and it will be an accident. But when we want to manufacture steel, we just surround it in a shield of argon, and that way the thing does not react, even if the temperature is so high that iron has literally melted. There is one application of this where we want to use, like if somebody would come up with an idea to use argon there, it will be very useful. Extraction of aluminium is done through carbon electrodes. I'll explain what carbon electrodes are and all that, but just remember that there is carbon and it has a huge involvement there when you try to extract aluminium. Now oxygen gas comes in and the temperature is really high, so what happens is that all the carbon simply burns and gives off carbon dioxide. Now carbon dioxide is bad for the environment, like a certain, more than a certain threshold, it is bad for the environment. It is a greenhouse gas, contributes to global warming. uh, Carbon burning is dangerous for that. Now for that, we secondly we have to import more carbon, we have to replace the carbon that we were using anyway. So if we were to come up with a method where we could surround that with argon and we did not have to let it burn at that high temperature, it will be very useful. Okay, so we still don't have that method, and I don't think it's easily possible. So that's the thing. Wherever we can, we try to make use of noble gases. Another reason why argon is so abundantly used is because it is present in a high quantity in the air. It is the third highest available gas in the air, like after nitrogen and oxygen. We have argon. So make sure that you write that down somewhere so that you can come back to it later on. So nitrogen is 79% in the air. People who are in IGCSE, you can write 80% as well. And oxygen is 21% or 20% in the air. And usually the third gas that is most abundant is argon, which is I think 0.8%, but again, you don't have to know that value. So that's noble gases. Noble gases are unreactive, which makes them very useful. And there are three gases for which you need to know the uses. Helium is used to fill balloons, neon is used to make neon lights, and argon is used to fill light bulbs. Similarly, argon is used to manufacture steel. Now, in the exam, if they say give two uses of noble gases, and you write neon is used to make light tubes and argon is used to make light bulbs, examiner will give you just 1 mark because you have just talked about applications of this in lights. You need to give two uses if the examiner says so. Instead of saying light tubes and light bulbs and thinking that they're different, I would suggest you go with manufacturing steel or you go with filling balloons to fill up for the second part. Okay. Another reason, another state that you need to know about them is that all noble gases are gases, like as the name suggests, they're gases at room temperature, which means that even radon and xenon, they are gaseous. Okay, so that is noble gases. Any questions about them or their usage? All right, great. Now let's talk about the other the other non-metal group that we need to know about. That is group 7. This one. Now, before we do that, I would like to show you these 8 atoms, and these elements are basically these ones. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, acetylene. You notice that this makes an inverted 7, right? Sorry, it makes an inverted L or 7 if you look at it. This thing is basically telling me all the atoms or all the particles that are diatomic. Okay, so these things, they are diatomic, which means that they are these are 7 elements here which exist as molecules of 2 atoms. Noble gases exist as individual atoms. These 7, and they make a 7 in the periodic table, literally a 7 figure. These are diatomic. There's one more. Can you think of another element that is diatomic, which is not in these? So that is hydrogen. Hydrogen is not in here, but that is also diatomic. When I say diatomic, what it means is that if you have to write the formula, you will not write N for nitrogen. Nitrogen exists as N2. Oxygen exists as O2. Fluorine exists as F2, Cl2, Br2, I2, At2. Okay? So that's what this being diatomic means. So these are all diatomic gases or liquids or whatever, but diatomic molecules. Now, group 7, these are called halogens. As you can see here, halogen is something that forms salt. So in most of the salts that we get, we have these things. Okay. Now, a few properties about them that you need to remember. First of all, the colors. Fluorine, chlorine, bromine, iodine, acetylene. As you go down the group, and I will keep on referring to going down the group. As you go down the group, the color darkens. So it gets more and more dark. As you can see, fluorine is yellow. Chlorine is green. Bromine is brown. Iodine is black. And acetylene is also black. So the color is getting darker and darker. Okay. So yellow here. This is yellow. This one is green. It is actually yellowish green, but you can just go with that. This one is brown. And then we have black. So this one is black. It should be black. I don't know. Is that black enough? Okay. And that's also black, although it will be a little more darker than that. The color, as you can see, is getting darker and darker. The reason why that is so, we don't study them, not even in A levels. Another thing, that as you go down the group, density increases. Now, you have talked about, or you'll know about kinetic particle theory. So can you tell me a reason why density increases as we go down the group?
The particles come more closer to each other.
Okay, that is what usually density means, but why would they come closer to each other?
The particle size increases.
Sure, particle size definitely increases, but that is true for every group.
Say basically उसमें ऊपर top में जो gases हैं and as we go down the group they become solids. So the attractive forces between the molecules increases.
Excellent. Very good. So the attractive forces between these particles are increasing. And the attractive forces are basically coming from the electrons. So as you go down, the electrons are also increasing in number. You can see fluorine has 9, fluorine molecule will have 18, obviously. Chlorine molecule will have 34 because Cl2. Bromine will have 70 because Br2. And as you go down, the number of electrons is increasing, which is increasing the van der Waals forces that they have. We will talk about van der Waals forces in a bit as well. So as you go down the group, forces increase, which brings them closer together, which means that they have higher melting points, they have higher densities as you go down the group. Again, these melting point and boiling point are not as high as you would expect for metals, but still compared to each other, they are getting higher and higher. So they're coming close together. They are having higher temperatures, and all the reason for that is that they have stronger forces of attraction between them. Okay, so why that force is higher? Usually, the question doesn't ask about it. Okay, now all of them will have 7 electrons in the last shell, but being a smaller atom helps when you are a non-metal, because the smaller the atom, easier it is for it to gain an electron and pull it towards itself. Because remember that the pull on electron is coming from the nucleus, which is at the center of the atom. So if you have a really big atom, it will find it hard to attract those electrons from the outside. But if you're a smaller atom, you find it easier to attract those electrons, which is why fluorine, for example, is very, very reactive. In fact, it is considered the most reactive non-metal. And chlorine is less reactive than that, and bromine is less reactive, and iodine is even less reactive. And the reason is that as you go down, the atomic size increases. And as the size increases, it becomes more difficult to gain electrons. Okay? Which is why they get less reactive. So remember this thing. They all want to get 1 electron. They all have 7 and they want to get to 8. But the bigger atom finds it hard to attract them. The smaller atom finds it easier to do that, which is why fluorine is more reactive. And as you go down, the reactivity decreases. This is a very important point because examiner usually tests students on this. Got it? So that's what halogens are and what the colors are and what the states are, and some properties that as you go down, the reactivity decreases because their size increases. It's difficult to gain electrons. And secondly, there are diatomic gases or liquid or whatever. For iodine, you also need to remember that iodine has multiple colors based on its state. So iodine is black as a solid, but when you put it in water or when you liquefy it, melt it, it becomes brown. So iodine and bromine are both uh, what you say brown when in liquid state, but iodine vapors are purple. Okay. Now some chemicals that are related to these that we use all the time. So bromine has a usage that bromine is used to test for saturation. So again, saturation, we'll get to that when we study organic chemistry, but remember that that's a fact you need to remember here. So this is used for test for saturation. If bromine reacts, the thing is not saturated, and if it doesn't, the thing is saturated. Similarly, chlorine changes the pH, so it is used to treat water. So water chlorination, so it kills bacteria in water. So that's also something you must remember. So when we are treating water, when we are making it useful for human consumption, then we add a small amount of chlorine to it so that it kills all the bacteria. How it does that is that chlorine reacts with water to make HCl and HOCl. Again, you don't need to remember the formulas. So it makes the solution acidic, and that acid then kills bacteria because they cannot survive at that pH. Similarly, fluorine itself is poisonous, but fluorides are added. So fluorides are added to make gums stronger or to help in gum, like fight gum disease. So fluorides are useful there. Although these fluorides are poisonous to uh, pets like dogs and all that. So just a side note, if you have fluoride toothpaste, don't use it on dogs or cats that you have. All right. Similarly, iodine is related to a compound, potassium iodide, which is a good reducing agent. So again, that is something that you have to remember, that iodine is given off when this reacts. So potassium iodide reacts to give iodine, which is brown in liquid. So potassium iodide aqueous is a reducing agent, and we use iodine to test for oxidizing agent. Okay, so this can also be useful there. So each of these has a particular compound which is useful, except for bromine, which itself is used to test for saturation. So just make a note there that you have to remember this. All right, now these, most of these are physical properties. I will talk about their chemical properties at the end of the lesson. All right, so they get less reactive as you go down, they have higher melting point as you go down, and they get darker, all of that. Okay, so just remember this. Nitrogen, you need to know that nitrogen is useful for plant growth, but it cannot be absorbed directly from the air. So nitrogen is then absorbed in the plants and all that. Could you explain your answer again? Your question, I don't understand what bond strengthens means.
No, sir. I said that about when you ask a melting point to increase. Okay.
Yeah, we won't say bond, we'll say force. The forces of attraction are
Okay.
getting stronger. Yeah. Other element non-metals for which you need to know about, for example, you need to know that carbon is inert. Okay. Similarly, note it down that carbonate gives carbon dioxide when reacted with acid. So that's an important point. Similarly, carbon monoxide, which is uh, a gas, is a good ox reducing agent. So carbon monoxide is that. Similarly, for nitrogen, you need to remember that nitrogen itself is useful for plant growth, but it cannot be absorbed directly, which is why we use nitrates as fertilizers, which are then absorbed by plants. So in nitrogen, remember about ammonia and nitrates. So nitrogen gas itself, then nitrate, then ammonia. So a few points about it. Nitrogen gas is the most abundant gas in the air. It makes up 78 to 79% of the air, and the test for it is not in your syllabus, but it extinguishes a flame if you have to ask, which is the reason why carbon dioxide test, if they ask you for carbon dioxide test, you cannot say that it extinguishes a flame, because nitrogen does the same. Similarly, ammonia, which is NH3, make sure that you write it somewhere. So ammonia is basic, which means it turns red litmus blue. So again, that's a fact that you have to remember. The next one is ammonium. It is NH4 with a positive charge. So ammonia and ammonium, those are two different things. NH4 with a positive charge, that thing is acidic, and note that it gives ammonia in a reaction or with heat. Similarly, there is another ion of nitrogen that's important, nitrate ion, NO3 with a -1 charge. That ion is important because, first of all, it is soluble in water. So all nitrate compounds are soluble in water. And secondly, it gives ammonia with NaOH. Okay. So just remember these small points about them and make sure that you write them. Similarly, about silicon, Si, remember that it is used in manufacturing computer chips. It is a metalloid. Metalloids are non-metals that act as metals sometimes. So non-metals with some metallic character. That's what metalloids are. They are essentially non-metals. Most of their properties are those of non-metals, but they have some properties of metals. So silicon is one of those. Similarly, for phosphorus, you have to remember that phosphorus is useful for plant growth. So add it to fertilizers. Not all of them on the staircase are metalloids. In fact, some of them beyond the staircase are also metalloids. But if they ask you for metalloid, just write silicon. That's good enough. Or arsenic if you want to. Okay, next one that is very important is sulfur. S. For sulfur, sulfur itself, not many questions are asked for it, but people doing IGCSE should remember that this is yellow solid. People in O levels don't need to know that. Second point that you have to know about sulfur is that sulfur has two ions, sulfate and sulfite. Sulfate is SO4 with -2 and sulfite is SO3 with -2. So sulfate and sulfite. Sulfate के लिए आप याद रखें that barium ion is a test for sulfate. As I was saying, sulfate. So sulfate is, so for sulfur, you need to remember that this is yellow solid again for IGCSE, not O levels. The formula for sulfur is S8 again for IGCSE, not for O levels. Sulfate and sulfite. These are two ions, sulfate, sulfite. Now, for these, both of them, you have to remember that they're tested with barium ion. So, अगर कभी भी barium ion आ जाता है ना, तो आपने आंखें बंद करके समझ लेना है कि सल्फेट का टेस्ट आ रहा है या सल्फाइड का टेस्ट आ रहा है. ठीक है? They're both going to give white solid with that. So you get a barium ion, you get a white solid, whether it's sulfate or sulfite. And extra note that sulfite is soluble in HCl. So that is extra for sulfite, which means you have sulfate or sulfite, you are not sure what it is. You add barium ion, it will give you a white solid. Good. So white solid आ गया, तो मतलब सल्फेट या सल्फाइड में से एक है. बट कौन सा है? HCl डाल दें. सल्फाइड will dissolve in HCl, सल्फेट will not. आपको इनका फर्क समझ आ जाएगा. Another thing you need to know about the sulfur family is SO2 and SO3. They're both acidic gases, so both are acidic gases. Both are responsible for acid rain. And remember that sulfur dioxide converts to sulfur trioxide if you have nitrogen oxide there. So this is a catalyst. So sulfur dioxide converts to sulfur trioxide if you have NO2 as a catalyst. Again, this is an example of catalyst that you don't need to remember, but you can if you want to. It's not exactly required in your syllabus. Now, test for these. So SO2 is a reducing agent. Okay. So it readily absorbs oxygen or reacts with oxygen. So the test for it is you get an oxidizing agent. Okay. So reacts with oxidizing agents. आपके सिलेबस में एक ऑक्सीडाइजिंग एजेंट है, KMNO4. So it turns colorless if you react it with sulfur dioxide. So purple KMNO4 turns colorless. SO2 का टेस्ट आपने ये ज़हन में रखना है, that it will simply react with it and purple to colorless color change हो जाएगा. So sulfur family में, yes.
सर ये ऑक्सीडाइजिंग और रिड्यूसिंग एजेंट क्या है सर? ये मुझे तक समझ नहीं आया.
ऑक्सीडाइजिंग एजेंट वो है जो ऑक्सीजन देता है और रिड्यूसिंग एजेंट वो है जो ऑक्सीजन लेता है एट द मोस्ट बेसिक लेवल. ठीक है, तो जो ऑक्सीजन ले वो रिड्यूसिंग एजेंट है और जो दे दे वो ऑक्सीडाइजिंग एजेंट है.
सर इसके अंदर गेन और लॉस ऑफ इलेक्ट्रॉन्स भी होता है?
वो भी होता है जी, बिल्कुल होता है, लेकिन वी विल गेट टू दैट व्हेन वी स्टडी इट इन डिटेल. अभी के लिए दीज आर फैक्ट्स दैट यू नीड टू पुट इन योर रिमेंबर, ताकि आपको बाद में आसानी हो. सो सल्फर फैमिली समझ आ गई?
जी सर.
Any questions about any of them? So now we know about sulfur, we know about carbon, we know carbon में मैंने आपको बताया था that you have two things. You have carbon itself, which is solid, reducing agent, black in color. Uses इसके क्या हैं? As fuel and in extraction of aluminium. फ्यूल के तौर पे कैसे होता है? जब ये कोल में होता है, ठीक है. यू कैन मेक पेंसिल्स फ्रॉम इट. जब ये ग्राफाइट है, यू कैन मेक इलेक्ट्रोड्स फ्रॉम इट. जब ये ग्राफाइट है,
सर इसका कोई
इन्हीं
होता है कि इससे एसिड रेन भी होती है सर?
अभी बताता हूँ मैं. ग्राफाइट है. सिमिलरली यू कैन मेक ड्रिल बिट्स जब ये डायमंड है. सो कार्बन की डिफरेंट फॉर्म्स हैं हमारे पास, जिनमें से डिफरेंट यूजेस हैं. Then we have carbon monoxide, we have carbon dioxide. Carbon dioxide is a certain percentage, 0.03, but you don't need to remember this. The test for SO2 and SO3 is the same, but for SO3 you have to do another test to differentiate between them. So there are basically two tests. So CO is again a reducing agent. Remember that this is poisonous. So these are small facts that we need to remember. This is poisonous. It will simply react and odorless है, तो हमें पता भी नहीं चलता है. Which is why we need to install carbon monoxide detectors in houses, especially in the kitchen where something is burning and all that. Yeah. Carbon dioxide के बारे में आपको बताना चाहिए कि turns lime water milky. ठीक है. And another thing you need to, this is the test for carbon dioxide. Then we have carbonate. Carbonate gives carbon dioxide with acid. So that's a test. In other words, it is destroyed by acid. That is also a term that examiner uses sometimes. That what do you need to destroy carbonates and all that? So this is destroyed by acids. Okay. So that's one thing you need to remember. Okay. तो अगर कार्बोनेट को टेस्ट करना है, सिंपली एसिड डालो, कार्बन डाइऑक्साइड निकलेगी. और कार्बन डाइऑक्साइड को टेस्ट करना है तो टर्न्स लाइम वाटर मिल्की. बात खत्म. ठीक हो गया. अच्छा, ऑक्सीजन इज द नेक्स्ट वन. ऑक्सीजन occurs as O2 and O3. This is called ozone. This has a layer which keeps us safe from harmful radiation. So harmful radiations are stopped by it. Another problem with this is that this causes photochemical smog. याद है लास्ट ईयर लाहौर में बहुत इशू हुआ था. So photochemical smog is caused by ozone. Oxygen is 20% or 20 to 21% in the air. It relights a glowing splint. ये इसका टेस्ट है कि अगर आपके पास शोला है, there's a glow that is there and you bring oxygen closer, it will start to burn. So the flame will be rekindled. Okay. Things that react with oxygen to form a compound, those compounds are called oxides. And oxides have a whole chapter or section dedicated to them. So for now, I will simply give you a little bit about them. That oxides are of four kinds. Oxides are acidic, neutral, amphoteric, and basic. When are they acidic? If they are from non-metals. When are they basic? When they are made from metals. When are they amphoteric? Aluminium, zinc, and lead. These three oxides are amphoteric that you need to know about. People in IGCSE उनको कुछ और भी मिलते हैं, लेकिन आपको ये पता होना चाहिए कि ये तीनों तो डेफिनेटली एम्फोटेरिक है. Similarly, neutral में carbon monoxide, nitrogen monoxide, and hydrogen monoxide, which is water. These are neutral. Not to say कि और नहीं हो सकते हैं, but ये definitely हैं. ये वो हैं जो आपको याद होने चाहिए. So anything that reacts with oxygen forms oxide. And those oxides can be basic or acidic. We will talk about in detail what acids, amphoteric, all these things are. Right now, we're building a foundation for you to understand the next 7 or 6 chapters that we have. So there will be many terms here that you might not remember or might be new to you, but that's okay. That's expected. So do you understand everything that we have to know about non-metal? All right, guys? Okay, great.
Sir, एक चीज दोबारा पूछनी थी.
जी पूछें.
Sir, what would be the separate test for SO3?
SO3, the test for it is not in our syllabus.
Oh, okay. So we only know the one that's true for both SO3 and SO2, right?
Yes. So these are the things for non-metals that we need to remember. In the next lesson, we are going to talk about metals. Now, one last thing about a couple of other non-metals. For example, hydrogen. It is also diatomic. It is also very light. And its test is that hydrogen pops in a flame. Now, many students, you sometimes write extinguishes a flame with a pop sound. You don't have to talk about it that it extinguishes or not. It sometimes extinguishes because it is explosive. So बहुत ज़्यादा अगर explosion हो जाए और oxygen की enough quantity ना हो तो वो extinguish हो जाए. But that doesn't always happen. ठीक है? Similarly, given off when metal reacts with acid. So hydrogen is given off there. Remember this thing. Whenever you have a reaction of metal and acid, you will get hydrogen. So obviously, if they ask you for observation, you can write that bubbles of gas are coming out. We will talk about that why that happens. So that is again for acid basis chapter. Okay?
सर
Yes?
सर ये जो ग्रुप ये जो हेलोजेंस है सर इनके ऊपर चार्ज ज्यादातर पॉजिटिव ही होता है ना.
No, halogens are the ones that are in group 7, which means they need to gain electrons. So to gain electron, they will obviously need to get electron, which is -1.
सर ये जो फिर
Usually in
2 और 3 ग्रुप के दरमियान है सर इनमें कौन सा चार्ज होगा.
We will get to that. Those are metals. We will talk about them in the next lesson. Now, the last and very important point for today is the reactions of displacement reaction of group 7. Group 7, you know, they are more reactive down the group. Now, the displacement term is going to be used multiple times in the syllabus. What it means is a more reactive species or a more reactive substance displaces or replaces a less reactive substance. और इसमें आपने एक चीज ध्यान में रखनी है कि observations, the new observations are for the displaced species, which means जो less reactive था ना उसकी observation नजर आएगी. जो ज्यादा reactive वो तो कर गया reaction. अब होगा क्या? Let's suppose I have any compound, let's suppose potassium iodide, कलरलेस होगा, पानी में डिसॉल्व किया है, कलरलेस है. इसका रिएक्शन करवा देते हैं ब्रोमीन से, ब्राउन होगी. क्या होगा? ब्रोमीन इज मोर रिएक्टिव, potassium iodide is less reactive. We will talk about how to write equations if you're uncomfortable with that. So bromine is going to come and displace it. This is like musical chairs. The more agile thing or agile person in musical chair, they sit on the chair and the other person is kicked out, right? That's exactly what's happening here. Bromine is more reactive. There is only one spot for non-metals. पोटेशियम तो किसी एक के साथ ही रह सकता है ना, दो के साथ तो रह नहीं सकता. तो उसने रिएक्ट करना है किसी भी नॉन मेटल के साथ, वो आयोडीन हो ब्रोमीन हो, वो तो उनका आपस का मामला है. तो क्या होता है, ब्रोमीन कम्स एंड डिस्प्लेसेस इट, उसकी जगह ले लेती है, एंड यू एंड अप विद KBr. अब KBr कलरलेस है, आप उसका कुछ नहीं बता सकते. अगर आप रिएक्शन कर रहे हैं आपको ये नजर नहीं आएगा कि क्या हुआ. आपको नजर क्या आएगा? आयोडीन बाहर आती हुई नजर आएगी. ठीक है? It's like watching a cricket match while you're not in the stadium, you're sitting outside. So every player that comes out tells you कि oh ये out हो गया. आपको नहीं पता अंदर क्या हो रहा है। यहां पर जब आप ऑब्जर्व कर रहे होते हैं, रिएक्शन कर रहे होते हैं, बीकर है, बीकर में हमने पोटेशियम आयोडाइड डाला, कोई कलर नहीं था, ब्राउन डाला, ब्राउन कलर हो गया। थोड़ी देर बाद वो सारा ब्राउन कलर चेंज हो जाएगा, ऑरेंज ब्राउन से डार्क ब्राउन हो जाएगा। तो आपको पता चल जाएगा अच्छा वो डार्क ब्राउन कलर जो है ये रेड ब्राउन कलर था, तो उससे ये खाली ब्राउन कलर हो गया है, तो दैट इज बिकॉज आयोडीन वापस आ गई है। तो आयोडीन वापस आई है, इसका मतलब है आयोडीन इज लेस रिएक्टिव। इट इज एविडेंस दैट आयोडीन इज लेस रिएक्टिव। आप यही केबीआर लेते हो और इसमें क्लोरीन ऐड कर देते हो, क्लोरीन ग्रीन है, केबीआर कलरलेस है, बट वी नो क्लोरीन इज अ स्मॉलर एटम है, तो वो उसको जल्दी रिप्लेस करेगा, पोटेशियम के साथ उसका रिएक्शन आसान होगा। So what happens is that this chlorine simply goes and makes KCl. Again colorless है, आपको पता नहीं चलेगा किधर गई। हाँ, ग्रीन कलर फेड्स, आप देख रहे होंगे अचानक ग्रीन कलर सारा खत्म हो जाएगा और ब्राउन कलर नजर आना शुरू हो जाएगा आपको। सो ग्रीन कलर फेड्स, रेड ब्राउन कलर अपीयर्स। दैट इज एन ऑब्जर्वेशन फॉर यू दैट शोज कि ब्रोमीन इज आउट। Same thing happens if you take this KCl or HCl or anything with Cl in it and you add fluorine to it. Fluorine is more reactive, it's going to come and take its place. And you will end up with chlorine, which is green. So now yellow color fades, green color appears. ये चीज बड़ी जरूरी है. You have to look at the equation and you have to understand that all the observations of reactants go away and all the observations of the products come out. So when the examiner asks you that what are the observations of this reaction, to look at the reactants and see कि जो वो है ना वो खत्म हो जाना है. तो अगर reaction solid है, you can write solid disappears. Reactant का color है, आप कह सकते हो ये color खत्म हो गया. And then you look at the products and you're like, अच्छा ये product में अगर liquid एक gas है तो आप कहोगे bubbles come in out. Product में एक color है, वो आप कहोगे ये color नजर आएगा. And that's exactly what happens here. In group 7, the less reactive thing is displaced by a more reactive thing. And the reason is कि जितना छोटा atom होगा उतना बेहतर non-metal के तौर पे react कर सकता है. So अगर वो आपसे कहता है कि test करना है to put halogens in the reactivity order or something, तो आप क्या करोगे? You'll be like सही है भाई. Take one which is less reactive, react it with the one that is more reactive. If the reaction occurs, we know जो हमने डाला था वो ज्यादा reactive है. अगर नहीं होता तो मतलब है जो पहले से है वो reactive है.